Today's lesson is domain and range. So let's start out with what our learning objectives are. I can state the domain and range of functions mathematically from graphs and equations by using set builder notation and interval notation by reading left to right for domain and bottom to top for range. I can determine the domain and range for real-world problems by applying appropriate restrictions for fractions, radical, and real-world situations. Take a minute now and then let's decide, where are we on the learning here? Is this something I'm hearing for the first time? I'm a novice, or I remember this all from Algebra 2, hands down, I'm an expert, or I'm somewhere in between. Okay, so let's start out with domain. Domain is usually referring to X. Okay, and the domain of a function is the set of all values, the inputs of the independent variable for which the function is defined, and the range, and we're referring to Y, the range of a function is the set of all values, the outputs of the dependent variable. For which the function is defined. Okay, we're going to be talking about set builder notation and interval notation. So we need to just review some quick open and closed or non-inclusive and inclusive symbols. So I want you to take a minute and sort these symbols into whether they are open, non-inclusive, or closed, inclusive. So pause the video and sort them real quick. Okay, so we've come back. So open would be referring to the open circle, closed, the closed circle. For the lines, the dashed line is open, the solid line is closed. Parentheses represent open, brackets represent closed. Greater than or less than represent open, or greater than or equal to, or less than or equal to represent closed. The only exception is when I'm talking about infinity. Infinity always uses a parentheses. So this is just a special case. Okay, so let's go inside on the notes here. And let's take a look at set builder notation versus interval notation. So I wanted to start out with understanding that when I'm talking about a number line, to the left I have negative infinity, and to the right I have infinity. I'm just starting out with that. So to get an idea, if I need to draw the number line for what I'm talking about, I'm going to do that. So here I have 3, and here I have 5. So to start out with set builder notation, so I'm going to say X is greater than or equal to 5. So if it's greater than or equal to 5, I have a solid circle, or greater than or equal to 3, and less than or equal to 5. So I am in between here. So I want to write this as an interval. So I'm starting at 3. I'm ending at 5. And to show that I'm including 3 and 5, I use a bracket. When I'm not including 3 and 5, I use open circles on the graph or on the number line. And I use parentheses to say I'm not including 3 or 5. If I just want to switch x is greater than or equal to 5 into interval notation, on the number line it looks like this. So I'm starting at 5 and I'm ending at infinity. I'm including 5, so a bracket. Infinity always gets a parentheses. If I'm not including 5, I would use a parentheses. So 5 to infinity. So 3, not including 3, but including 5. So greater than 3, but less than 5. So greater than 3 and less than 5. I'm not including 3, so a parentheses, and including 5. That gets a bracket. Okay, so let's start out when we're talking about the domain. What is the domain? When I have no restrictions. So no restrictions at all. My domain in words is all real number. In symbols, oops, hang on. Whoa. In symbols, this is that double R that we've seen. And in interval notation, this is from minus infinity to plus infinity. So if I'm talking about a domain that has 0 restrictions in words, it's all real numbers, the double R, or from negative infinity to positive infinity. So right now we're starting out with, I'm looking under 2 cases, and then I have to restrict the domain. So the first restriction I want to look at is when I have a fraction. Oops. When I have a fraction, or when I have a radical that has an even index. So my restrictions, so when I have a fraction, I know I can't divide by 0, so I am just interested in what's going on in the denominator. I'm not worried about what's going on in the numerator, just the denominator. So if I factor this denominator, I get x plus 2 and x minus 2. And when I'm solving, I get x equals negative 2 and x equals positive 2. So I say I can be all real numbers except x cannot equal plus or minus 2. Oops, here we go, I'll do this one. Plus or minus 2. Okay, so next I'm looking for when I have radicals and I'm only looking at an even index. So starting out with, this is my radical symbol. What's under the symbol is called the radicand. And the number I see over here is called the index. If there's no number, the index is 2. So I'm interested in just radicals that have an even index. So an even index is the square root, or the 4th root, or a 6th root. I'm only interested in the even roots, and the restriction is the radicand has to be greater than or equal to 0. Okay, I can't have a radical with an even index of a negative number on the real number system. So for negative index, which is the 3rd root, or the 5th root, or the 7th root, there's no restrictions. These are okay. All right, so let's go do some examples of finding the domain. All right, so here if I have a set of ordered pairs, and I asked you for what the domain is, I know domain is x. So I'm looking at what are all the x coordinates. And when I tell you what the domain is, I put them in braces, and I would put them from least to greatest. So -3, -1, 0, 2, and 4. All right, so let's look at some equations. So I'm looking at number 4, g of x equals -3x squared plus 4x plus 5. So I'm looking at this equation and I'm asking myself two questions. Do I have a fraction? No. Do I have a radical with an even index? No. So I have no restrictions. When I have no restrictions, that means my domain is all real numbers or all real numbers. I can say it either way. They're both correct. Let's look at number 5. I am looking at and I'm asking myself two questions. Do I have a fraction? Yes. So this is a fraction. Since I have a fraction, I'm looking at the denominator, and the denominator cannot equal 0. So I say x plus 5 cannot equal 0 because I cannot divide by 0. So I'm going to subtract 5 from both sides, and I get x cannot equal -5. So I'm all real numbers except -5. Let's look at number 6. I'm asking myself two questions. First question is, do I have a fraction? Yes. So with a fraction, I'm interested in what's in the denominator. In the denominator, I have x squared plus 1, and that cannot equal 0. So x squared plus 1 cannot equal 0. So solving for x, I'm going to subtract 1 first. So I get x squared, subtract 1 first from both sides. So x squared cannot equal -1. This is not possible. I cannot multiply two of the same numbers together and get a negative number in the real number system. Since that's not possible, I have no restriction. So my domain is the set of all real numbers, or I could say it in interval notation of -∞ to +∞. Number 7. So I'm asking myself two questions. Do I have a fraction? No. Do I have a radical with an even index? So since I have no number here, my index is 2. So I have a radical with an even index. Since I have a radical with an even index, I'm looking at what's under the radical. So x minus 3. And I know that cannot be negative, so it has to be greater than or equal to 0. So solving for x, I'm going to add 3 to both sides, and I get x has to be greater than or equal to 3. Okay, 3 more practice. Okay. All right, next one. I'm asking myself two questions. Do I have a fraction? No. Do I have a radical with an even index? Yes, because my index is 2. So I'm interested in what's under the radical. So this is x squared minus 9, and this has to be not a negative number, so greater than or equal to 0. So I get x squared is greater than or equal to 9. I'm going to take the square root of both sides. So when I get the square root of both sides, then I have a number line. And since I am greater than or equal to, so I know I have minus 3 and plus 3. So now I want to know, am I in between the minus 3 and the plus 3, or am I on the outsides of the minus 3 and the plus 3? If I'm not sure, I just want to test a number. So to me, you can use any number in between or on the outside to see if I am true or false. I think a good choice would be 0. So if I substitute x as 0, is 0 squared greater than or equal to 9? And that would be false, or on my calculator, I'd get an error. So that means this is the part of the graph that I'm talking about. So now I want to write this interval and this interval together. So over here, this is minus infinity and this is plus infinity. So to write this is from minus infinity to negative 3. And I'm including 3, so I use a bracket. And we say the union of 3 to infinity. And again, I'm including 3, and I'm including it because I have the equal sign. All right, let's try the next one. So I'm asking myself 2 questions. Do I have a radical or a fraction? Yes. And do I have a radical? So this is an example where I have both restrictions. So I have a fraction and I have a radical with an even index. So I need to combine the 2 restrictions. So for the fraction, the denominator cannot equal 0. And for the radical, I have to be greater than or equal to 0. So together, this means just the radicand is greater than 0 when I have these 2 restrictions together. Okay, so if I'm going to take what's my radicand is x minus 3, has to be greater than 0. Solving for 3, I'm adding 3 to both sides, or solving for x, adding 3 to both sides, and I get x is greater than 3. Okay, so at this point, we've just talked about restrictions that are associated with fractions or radicals. So now let's talk about a real world restriction. So if I'm talking about the equation of the volume of a sphere is 4/3 pi r cubed, and I'm asking myself 2 questions. Do I have a fraction? So yes, I have a fraction, but the fraction is with the constant. And I'm only interested if I have a fraction with the variable, and the variable is r cubed. So r cubed is not a fraction, so I'm not worried about the denominator, and it's not a radical. So I don't have either of those math restrictions. But in the real world, if I'm talking about a sphere, I cannot have a radius that would be 0 or negative. So I would have to apply a real world restriction to say the radius has to be greater than 0. So even though mathematically I could have a negative r or 0 for r, in the real world I can't. That's the end.